This lesson talks about the law of sines and the ambiguous case. We only have to worry about the possibility of having two possible triangles only when we've been given two sides of a triangle and an angle that is not included in between the two sides. So, for example, in this case, in this triangle, let's say I've been given this angle right here as angle A, and then I would have been given side A as well as side B. Okay, so we know that these certain dimensions are forced. This angle right here, angle A, has to be frozen to be at this degree measure. Side A has to be this particular length, and side B has to be that particular length. What is not determined is how long side C is. And our angle for angle C and side B are also variable. Nothing's been determined about them, just the length of side B right here, the angle for angle A, the angle measure, and then side A is determined. Okay, those are fixed. So what can happen is, because we don't know how long or short side C is, in some cases, side A could actually land inside of the triangle, creating an obtuse angle for angle C. In this case, angle C is obtuse. In this case, or actually not angle C, angle B is obtuse. This would be angle B here. And then this would be an acute angle B. So the two dimensions that are differentiated are angle B and then side C. So depending on how everything works out, given the certain situation that we might be given, we might have an obtuse angle in our triangle or an acute angle in our triangle. Okay, so here's an example. Okay, so here's an example where we're giving angle A as 49 degrees, side A is 12 feet, and side B is 15 feet. To use the law of sines, we must have a side and its corresponding angle. So we would start with using the law of sines because we have that pairing, and we want to find angle B. So I'm going to put the sine of angle on the top, sine of the angles in the numerator. Sine of 49 degrees over 12 is to the sine of angle B over 15. When I do all the proper algebra for that, I find out that the sine of B equals 0.9434. And then, so the sine inverse, or the inverse sine of 0.9434 gives us our angle measure for B, so it tells us that B is equal to 70.628 degrees. Okay, so that is possibly my ambiguous, or my angle that could also be supplementary, but I'm going to put finding out whether or not that works on hold until I solve this triangle right here that I have with B being acute. So I can quickly calculate the measure of angle C as being 180 minus angle A of 49 and minus angle B at 70 and some change, and I find out that angle C will be 60 degrees, 0.372 degrees. So now I know angle A is 49 degrees, angle B, and angle C. The only part of this triangle now that I don't know is side C. So I'm going to use that, and I'm going to use the part of my proportion here that I know for a fact because I was given it. So I'm looking for a side length, and so I'm going to put my side lengths in my numerator this time. Sine of 49 degrees is to the side C, which that's my unknown, times the sine of 60 degrees, 0.372. Whoops, I put my little degree symbol in the wrong spot, sorry. Okay, so when I do the algebra here, I will be doing 12 times the sine of 60.372 divided by the sine of 49, and that's going to allow me to find out that C is 13.821 feet. So I look at my sort of statistics that I have here, not really statistics, but my facts of my side lengths and my angles, and I want to do a reasonableness check. And I'm going to say, well, side B is my largest side. This is my largest side. Is angle B my largest angle? Yes, it is. It is my largest angle. Okay. Side C is my middle length. Is side C my mid-angle? Yes, this is my mid-angle. And side A is my smallest angle, or smallest side and smallest angle. So that all works. Okay, but the question is there another triangle somewhere? So let's see what happens here. Okay, so in our first figuring using the law of sines, we found out that angle B is 70.62 degrees. Right there. So let's see if can angle B be obtuse. Well, the supplement of angle B, the supplement of B is 180 degrees minus 70.628 degrees, which would be, sorry about the room, would be 109.372 degrees. Okay. But we know, so that could be angle B possibly. We already know angle A is 49 degrees. And if that is all the case, then we're going to find out that angle C, once we add A and B together and subtract from 180, we will find out that angle C then would be 21.628 degrees, because they all have to equal 180. Okay, so I guess that could work, right? Okay, so let's use our law of sines again, and we will do 12 is to the sine of 49 as C is to the sine of 21.628 degrees. And when we do all of that on the calculator properly, we find out that C is equal to 5.86 feet. Okay. So that seems reasonable also. So again, putting it together with B at 15 and A at 12 feet, I want to check and look at this. And I want to say, okay, now C looks like it's my shortest side. And is it across from my smallest angle? Yes, angle C is now my smallest angle. Angle A is my medium angle, and side A is my medium side, and side B now became my longest side, and it is my longest angle. So that seems to all work together and be logical. Now, I think a lot of people get confused, and they say, well, how do you know it's B that is the ambiguous angle? Well, sometimes you just have to kind of continue to figure things out. And so what I would do is I might say, well, how do I know that C is not the obtuse angle? And so let's check on this work. Okay, so can C have, or can C, actually I should be writing, can C, yay, my eraser's working. Okay, can C be obtuse? That's a better way to word that, because any angle can have a supplement. Well, most anyway. Okay, so can C have a supplement? So let's do 180 degrees, and I'm going to use the original C that we got in our original work. This is supposed to be minus. 60.372 is our angle C. I'll clean this up a little bit. So I'm finding the supplement. 180 minus 60.372 would make angle C supplement be 119 degrees. Okay, and if A is still 49, oops, hang on. It's not moving. Hang on. A is still 49 degrees, and that would mean that angle B, this is angle C, this is angle A, and so angle B then, in this case, would have to be 11.372 degrees, which seems reasonable. Okay, but let's apply right away, looking at, without doing any more work. If you look at the given information, we had side A being 12 feet and side B being 15 feet. Well, look, we're supposed to have our sides are in proportion to our angle measures. And in this scenario, angle B is smaller than angle A, but side A is smaller than side B. So it doesn't work in the small, middle, large dynamic that has to happen. The smallest angle needs to be across from the smallest side, and right there, that just doesn't work right there. Okay, angle B is not across from the smallest side. So that makes this fail. Now, sometimes, given certain circumstances, I think it's valid for you to go ahead and try to make sense of whether or not this third case can work, or even the second case can work. At some point, it's not, there will be circumstances that just don't work out right. Your sign value becomes greater than 1. That's not possible. This proportional large angle being across from a smaller side, that doesn't go together, so the triangle doesn't work that way. Okay, so our triangle, again, has to be, side angle. So here's, I'll try to draw, I guess that's reasonable to be a 49 degree angle. We'll call this side B, which is 15, so this was our angle A. And here's our 12-foot side, okay? And so here's our angle B. And so the scenario was, here is B when it's the 60.372 degrees, and here's the obtuse version of it, working with me that you can understand that my drawings would never be perfect. Here's the scenario where B would be 109.372 degrees. Okay, and then this side is still 12. So you can see how that can work. You really do just have to use your law of signs and think about things. Are they making sense? So I hope that helps, and I will see you tomorrow.